One, we are live to the entire world right now. Okay? So these are the notes from me. Now,
Can you make a comment?
all of these, every problem we're going to be doing today that we're going to be going over, notice I drew 3 examples here. We're not going to do these. These are just like what we look like. We're always going to have a power like this one, an x to the 7th, then we're going to have it to another power. Some people, as I said, they call this stacking the exponents. Okay? And it could look simple like this one, where you just have x to the 7th and then to the 8th power. Or you could have a coefficient like this one here, where you have a 3y to the 5th and then stacked the extra power is the 4th. Or you could even have fractions. And we're going to go over all cases. What do you do when you do these, okay? And we're going to go over, so we're going to start on page 607. And I am going to zoom this in so it gets nice and big, even for the people watching this in Bosnia. My good friend Yuri, hello. He lives in Bosnia. Ladies and gentlemen, that was Matthew De La Cruz right there, who showed complete ineptness in geography for the world, because he has no idea where Bosnia. Bosnia is that state that's right below North Dakota. Yeah. Okay, so we're going to go over on page 607, A and C, and then we're going to flip it over to 608 and go over 3 of those examples. Okay. So notice this problem asks us, what is the simplified form of each expression? So notice we have p to the 5th power, and then stacked on top of that we have a 4th power. Okay, guys, very simply, when you have a power stacked on top of a power, what do you do with the exponents? To simplify, you multiply. Okay, so to work this out, to simplify this, we would keep the base of p, and then we would just simply multiply the 2 exponents together. So this problem would simplify into p to the 20th power. Okay? Now, if you're wondering why that is, why do you multiply the 5 and the 4? Here's why. You guys, that outside exponent of 4 actually tells you to repeat p to the 5th multiplying itself 4 times. So really this problem tells you to take p to the 5th and it tells you to multiply it by itself 4 times. That's what this problem is really telling you to do. It's telling you to do what we call repeated multiplication. And we've talked about in class over the last couple days, all week long as a matter of fact, when you multiply, what do you actually do with the exponent numbers? You add them. Well, if I add it up, 5 plus 5 plus 5 plus 5, you will see, does that indeed actually equal 20?
Yes.
So here's my question. What's easier for you to do? To simply multiply them or to write it out as repeated multiplication? Write it out. So if it's easier for you to write it out as repeated multiplication and then add the exponents up, do it. Or if you remember, when you have a power stacked on top of another power, just multiply. Okay, when we get to C, whoops, I went off the screen there. Hold on. Let me find it again. I lost it. There we go. Okay. Now, guys, when the exponents are fractions, it's the same rule. Okay, I'll say that again. When the exponents are fractions, it's the same rule. And if you wanted to do the fraction exponents as a repeated multiplication, I would not suggest it at all. Why? So just remember, because it would just get very complicated. So when you have an outside exponent stacked on top of an inside exponent, you multiply the exponents together. So to simplify this problem, you would keep the base of p, and then you would multiply the 1/2 times the 1/4. Okay, now remember when you multiply fractions, you don't need a common denominator. So when you multiply fractions, you just simply go 1 times 1, and you just simply go 2 times 4, you just multiply straight across. So this answer would simplify to p to the power of 1/8. Okay, Yeah, multiplying fractions is a lot easier than adding fractions. Okay? So any questions on example A or example C? All right, turn it over to page 608. Okay, now, if you notice in example A, this is a combination of the two rules we've been talking about. We have a multiplication where we're multiplying x to the second times x to the 6, but we also have power to a power with the negative 4 stacked. So I'm about to ask you guys a question. Do you think you should add the 2 and the 6 up first, or do you think you should deal with the negative 4 outside the parentheses first? Which one?
Negative 4.
Yeah, you guys, listen. Yeah, it's like PEMDAS. You take care of the outside exponent first, and then you simplify further than that. So, now here comes my next question. That negative 4, is it stacked on top of the 6?
Yeah.
Obviously, yes. Is that negative 4 also stacked on top of the 2?
Yes.
No. So the only thing you're going to multiply is the 6 and the negative 4. So to simplify this problem, x to the second is going to momentarily just stay x to the second, but then I'm going to have to multiply the 6 times the negative 4, and that's going to make my new problem x to the second times x to the negative 24th. 6 times negative 4 is negative 24. Now, how do I know that this is a multiplication problem? There's not a dot. So how do you know it's a multiplication problem now?
No parentheses.
Well, there's no parentheses. Right. If you see, you guys, if you see two things next to each other and there's no symbol between them, no addition symbol, subtraction symbol, division symbol, it means you're multiplying. So now you got to remember the multiplication rule. What do you do with the exponent numbers when you're multiplying? You add them. So this problem, I would have to add the 2 and the negative 24 together, and that would give me an answer of x to the negative 22 power. Now, by the negative exponent rule, you can't leave an answer with a negative exponent. So what do you have to do? You got to flip it. So what's my answer? It would be 1 over x to the 22 power. So in part A, that would be your final simplified version for that right there. And hey, Dorothy, we're not in Kansas anymore. I want you to notice that to get from the, and by the way, gentlemen, in the middle, I want you guys to notice that this took me 1, 2, 3, 4, 5 steps to get to my simplified version. So when I say we're not in Kansas anymore, we're not doing easy like, oh, it's only going to take me 1 step to get to my solution type of stuff. It's going to take you multiple steps. And you guys, I would say watch out, write out each step. Be very careful. If you try to do it all in your head at one time, your chances of like making a mistake are kind of bad, or they increase. Okay, part B, notice we have w to the negative 2 power, then we have parentheses w to the 5/3, and then we have stacked on top of that a 3. So once again, you have to deal with the outside exponent first. You have to simplify that first. So that 3, I have to multiply by the 5/3. So when I simplify this, I'm going to momentarily ignore the w to the negative 2 power, but then I'm going to have to multiply the 5/3 times 3. Okay, 5/3 times 3 is just 5. These 3's would cancel each other out. So this problem would become w to the negative 2nd power times w to the 5th power. Now what's the rule? What do you do with exponents when you multiply? You add them. So to simplify this, you would keep the w as the base, and you would have to add up the negative 2 and the 5. So this problem would simplify to w to the third power. Okay? Now, this one only took 1, 2, 3, 4 steps to get to my final simplified expression.
I have a question.
Robert Vargas, ask away.
Why do you have to say my last name?
So everybody in the world knows you.
Why does 5 to the third power multiplied by 3 change to a 5?
Watch. 5 over 3 times 3. I'm going to think of 3 as 3 over 1.
Oh, that's right.
If I didn't cancel out and I just multiplied straight across, I would get 15 over 3.
So that's
What's 15 divided by 3? 5.
Oh,
So ultimately the answer is 5, but if you recognize that you could just cancel out those 3's right away, you could just go boom, the answer is 5.
okay.
Is North Dakota
Matt
in US?
De La Cruz. What?
Is North Dakota in the United States?
Moving on to C. Okay. No, North Dakota is south of South Dakota. That's why it's called North Dakota.
It's in Canada?
Dakota?
No, because if it's south of South Dakota, then it becomes South Dakota, which is like 2 negatives, which makes it a North Dakota. Yeah.
It's worse than that now.
Okay. C. Okay, you guys. All right. Shh. Okay, part C. Once again, I have an outside exponent, but notice in this example, the outside exponent is for the first parentheses. So the first thing I need to do is I would have to multiply the negative 5 times the negative 1/2. And then I'm going to momentarily not forget about, but I'm not going to worry about the s to the 3/2 power. I have to multiply first. Okay, now, anybody want to take a shot?
I would like to.
What is negative 5 times negative 1/2?
2.5.
That would become, don't give me a decimal, we have to leave things as fractions. 5 over 2. It would become s to the positive 5 over 2. And then I'm going to multiply that by s to the 3 over 2 power.
Oh, that's why.
Okay? Now, what do I do with the exponents now when I multiply? I add them. So this problem would become s to the 5 over 2 plus 3 over 2. Okay? You guys, what's 5 over 2 plus 3 over 2? 8 over 2. So this would become s to the 8 over 2.
You can't see it.
Whoops, sorry. There we go. What does 8 over 2 divide into? S to the 4th power. So ultimately, this problem would simplify to s to the 4th power. Okay? There we go.